Hello, calculus student. This video is for chapter 3.6, the chain rule. Chain rule is a very important skill in finding derivative. So other than power rule and trig function derivative rule, we learn quite a bit of rules to find derivative if someone gives you a function. But there is a need for finding something that is in a function that is in the form of a composite function. So what happens is if we have, so why do we need chain rule for composite functions? So isn't like most of the functions are polynomial and trig function, and that should be sufficient. So what happens is if I have a function that is what the need for a chain rule or composite. The really basic one would be like this. If I want to do y equal to sine 2x, it's a very common function, or sine or cosine pi x. You know, we use it a lot to model things. What is a derivative, right? Because we have the derivative rule for sine x, but we don't have one for sine 2x. Can I just do cosine and then do the derivative like this? It's not. This is actually a composite function. The outside function is sine. The inside is 2x. So it's composite. This is outside. And inside, instead of x, my inside is 2x. Right? So you can think of it as the outside is f. And the inside is the g function. Your input is always just x. You multiply by 2, being the inside, and then you apply sine x. But this has no derivative rule to do. We only have a derivative rule for sine x. So this is a trouble. It's kind of like the need, a very real need for it. The other one that we might need help on is, what about if I have sine square x or sine 4th x? Now you may say for sine x is for the notation y. I hope that you know that this means sine x itself square, right? Then you may say, well, I would just use a product rule, sine x times sine x, and then we just do the product. But if it is more power, like this is equal to sine x to the 4th power, then it's a little harder. But you will notice that, well, can I use the power rule? But this is not x. But we can look at it as the outside function being a square function. F is the square function. This is the outside function. It's squaring something. But the inside function is sine, right? So we need some function composition or some rule to handle composition for this kind of situation. And then the third one is not just for sine and cosine, it's for a regular polynomial function. If I want to do square root of, this always happens, so this 1 minus x squared, remember this is a half circle. It's a very popular kind of function, the half circle function. I want to find a derivative of it because I want tangent line. So how do I do this? I know how to do square root. I know how to do square root x, right? Square root x is x to the 1/2. I can do power rule, but I don't know how to do square root of 1 minus x squared. But if we analyze it as the inside is 1 minus x squared, the outside, the square root is outside, then I can do it. So all these are very common functions that you see in daily life, but we don't have any derivative rule for it because these are composition functions. So that's why we would need chain rule. Chain rule is to handle function composition. So let's return to the notes. So and also this is a review on how you write sine 4th x. Okay, so 3.6 chain rule. So what it does, there's two ways of handling chain rule. One is to write your original function as h of x, and then is a composition of f and g. G is the inside, f is the outside. And we say the derivative of the composite function is h prime of x is, you do the derivative of the outside only. Outside, keep the same inside, plug it in, and then multiply with the derivative of the inside. Multiply with the derivative of the inside. So this is a function notation using prime. H prime of x is f prime of g of x times g prime of x. You can also use the dy dx notation is if y is a function of u, then dy dx is dy over du times du over dx. So it seems like this is a fraction and you can cancel it, so you get dy dx, but they are not. So this dy dx is just a differentiation process. So you can do a differentiation of y with respect to u's. We call it with respect to u. That means you use u as the unknown, and then do the derivative of u with respect to x. So the way we do it is, so both are popular. Okay, the way we do it, I'll do an example. The first is y equal to sine u, but u is 5x minus x. So basically your function is y equal to sine of 5x minus 1, but you write it so that u is 5x minus 1 and you would have a sine u for y. So find dy dx, I'm going to use the dy dx Linux format. Dy dx is equal to dy du first times du dx. So dy du means d du of what is the y? Y is sine u, right? Times, remember it's time. So d dx, what is u? U is 5x minus 1. Then we just do them. So just sine of u, the derivative we know is cosine. Cosine u times derivative of 5x minus 1 is just 5, right? And then we don't write cosine u because we're doing dy dx. Everything has to be in terms of x. We just write cosine of 5x minus 1 times 5. This times 5 is actually outside, so you should write it as 5 cosine 5x minus 1. So that's the derivative of this composition function. Another example, there's a lot of example, is if we have y equal to 4u cubed, that means, and then u is 5x plus 2, find dy dx. Okay, so use the dy dx is equal to derivative of y with respect to u. Just pretend that we're just doing u times du dx. So so that means you would do the derivative of u of 4u cubed, okay, times derivative of x of 5x plus 2. So the first will become power root 12 u squared times the second is just a 5. Okay, so then if you multiply this, it will be 60 u squared. But we are doing dy dx, everything has to be in terms of x. U will replace it with 5x plus 2 squared, and that's the answer for dy dx. More commonly, most of the time we don't write a function as function of u and something like that. We actually have to do our decomposition ourselves. So see if we can do it by ourselves. So for example, my function is y equal to, I should say y equal to sine 4 to the x, and we want to find dy dx. So the way to do it is look at what is outside. Sine 4x means sine x to 4 power, right? Write it properly, sine x to the 4th power. And obviously the 4th is the outside function and this is the inside function. 4th, you're doing 4th time outside. Inside is a sine x. This is inside. So we'll say to do the derivative of that, we would do the outside first. So this is, you treat this as the u. So do the outside is something to the 4th. If I want to do a derivative of u to the 4th, what would it be? It would be 4 u. I don't write u, but it's actually sine x. Keep it. And then to the 3 time. And then have multiplied the derivative of the inside, which is derivative of sine x. You see, when I do this without the u, I just keep on writing sine x. I don't change it. It's kind of like a placeholder. Now I do a derivative of this. So that would equal to 4 sine x cubed times cosine x. That is the derivative of sine 4 to the x. Let's do another one that has a form like this. I should say y equal. So y is equal to 5x squared plus 2x to the 6th power. I want to find the derivative of it. So identify outside. Outside is the 6th power, right? So this is outside. And what is the inside? The inside is 5x squared plus 2x. So I'm going to do the outside first. So this is inside. And for the inside, I just keep writing this. So dy dx, so I do not use u now. I just pretend this is u. So it will be u to the 6. So I'm going to do for 6. And then the whole inside 5x squared plus 2x don't change because this was u. 6 minus 1 is 5 times d dx of the inside of 5x squared plus 2x. What would that be? So this I just copy it. 5x squared plus 2x to the 5 times. To do this is multiply 10x plus 2, right? And that's the final answer. I think there is no common factor or anything, so that is the common. That is the answer. So if we know this, you will notice that a lot of time our outside is just a power rule, right? It's the power of something. We want to do it as a power. So we have something called a general power rule. That means if my h of x is equal to inside a function and then to the power n, then in general, h prime of x would just be n times of g of x. Just rewrite the g of x n minus 1 and then do derivative of the inside. That's what we were doing. A lot of the chain rule is applied this way. So we'll do this. Let's try this. A derivative of y equal to 1 over 5x 23 plus 1 square. So can I use the general power rule to do? I could use a quotient rule, right? I could use a quotient rule, but well actually the quotient is a square, so it's quite difficult to do. So I can rewrite it as, rewriting it first, as 5x to the power 23 plus 1 to the power negative 2. So I have g of x and a power. Okay, use general power rule. So that would equal to, so we say dy dx would equal to negative 2, because n is negative 2, to the power of 5x 23 plus 1, negative 3, because negative 2 times d dx of the inside of the g of x, 5x to the power 23 plus 1. So it turns out that is equal to, okay, so this is from the other side, negative 2, 5x to the 23 plus 1, power negative 3 times 5 times 23 is what? 115, right? Times 115 to the power of 22. And that's the final answer. Now let's combine this. 115 times negative 2 is negative 230. And then because if they're constant, we need to, oh, so this is a negative. So let's put in the denominator because we don't like negative denominator, negative exponent. The top would just be negative 230 x to the power 22 divided by 5x to the 23 plus 1. And that's the final answer. Okay. This is x to the 22 is this term. Okay. So I'm going to stop here and we'll continue with 3.6 part 2.